Right, wonderful people, let us continue in our work of calculating the derivative from the very definition that we have learned from. So I'm just going to draw up a line. This is where we finished off, and we're just going to build on top of this. Right, suppose the question comes and say that we should differentiate a function x divided by x minus 1 using the definition. Alright, we know that the definition would tell us the following. Now we know where we see x, we will be writing f plus h, so I can say f at x plus h, and this is equals where I see x, I'm writing x plus h divided by x plus h minus 1. So meaning f prime of x is equals to the limit. Remember I said we will be using the definition. The limit as h tends to 0 of f at x plus h minus f at x divided by h. And then from here what we can do, remember we have to keep on writing the limit, and from here what is it that I write? Now remember I have my f at x plus h, which is equals to this, so I'm going to say x plus h, x plus h minus 1. I'm going to subtract f at x, and what is my f at x? That is x divided by x minus 1. That would be my f at x, and remember all this has to be divided by h, and you have to keep on writing the limit as h approaches 0. Now there's something that I can do here. I can take out an LCD. Since I have a fraction and a fraction separated by minus, I can take out the lowest common denominator, and that would be x plus h minus 1 and x minus 1, since they are two different things. This is very, very important for us to understand this. This into this goes once, and this times this would be x plus h, x minus 1, subtraction sign. This into this goes once, this times that would be x plus h minus 1. And remember all this has to be divided by h. Please do not make a mistake there. And the limit as h approaches 0, you can remove the brackets using the distributive law, and you will get your x squared c x squared minus x minus plus xh. So this is minus x plus xh minus h. When you multiply there, you'll get minus h. Minus, you can multiply here and get minus x squared minus xh plus x, something worthy of noting. Divide by the LCD, sorry, x minus 1. And I'm going to change immediately division to multiplication, which is the limit as h tends to 0. Now look, this is positive and this is negative. This is negative and this is positive. This is positive and this is negative. In the basic, the fundamentals. And now check h with h, and then there's nothing left on the numerator, and we will say we are left with 1. And on the denominator now we have the following. We have x plus h minus 1 into x minus 1. Do not forget that. Now when we are here, we can almost let h be equals to 0. Or do we have to for example solve that further? That is fine. We can try and do that, no problem at all. So what we can do in here is to continue to say the limit as h approaches 0, and I can remove the brackets here. I can have x squared plus xh minus x minus x minus h plus 1, and I can have the limit as h tends to 0, and I can have my x squared, let's check, and I can have my xh minus 2x minus h plus 1. This is something that I can have there, and by just looking into this, what is it that I can do? Now let's look at something here. Okay, this with this, this with this, this with this, 1 over this. Alright, let's try to look at something here. Oh, sorry guys, look, when I said h should subtract an h, I forgot the negative there. I'm very sorry, I forgot the negative there. Alright, and then how do we go about doing this? Alright, I don't think I even have to do this, but that's fine, that's fine. So let's allow now h to be 0, so that we have minus 1 divided by x squared. Everything with h will go to 0, so we will have x squared minus 2x plus 1, and I can solve this. This can be factorized. Let me show you. We have x and x, we have 1 and 1, minus and minus, which is minus 1 over x minus 1 squared. This is what we get here. Now you didn't have to go and do this lot of thing that I have done here. Immediately when you are here, you can just say the limit as h approaches 0 of minus 1 divided, this h becomes 0, so that you have x minus 1 into x minus 1. Can you see that? If this becomes 0, you have x minus 1, which is the limit as h approaches 0 minus 1 into x minus 1 squared. Please do not go for this path. It's a tiring path, very tiring. So don't go for this, just simplify it in this way. Right, so that would be the derivative f prime would be equals to this. Very important. Now let us look at another example. Find the derivative of f at x equals the square root of x for x is bigger than 0. If you have watched my tutorial, we drew many times the function f at x equals the square root of x, and we looked at the domain and so on. You might want to go and look at the tutorials of Papa Fanzo as to how I have dealt with that. Now how do we go about solving that using the definition? That is one question. How do we go about doing that? Right, okay, that is fine. That is very much fine. So what is it that we are going to do then? Now one thing that I want to point your attention to is that the alternative formula for the derivative is the following. So this is the alternative formula. It says that f prime of x is equals to the limit as z approaches x of f at z minus f at x all over z minus x. This is the alternative formula for the derivative. Right, and then why am I introducing this alternative formula for the derivative? It's because we want to solve this problem that we are having here. We want to find the derivative of this. Now, what is going to transpire here? We're going to apply this formula on this. So in other words, we are going to say the limit as z approaches x will be equals, so where we see x we will be writing z, very important, minus f at x, which is the square root of x, divided, what is the value? We have z minus x, very important. And then from there, what is it that we can do? Now the limit as z approaches x. Now there's something that I can do here. I can rationalize the numerator, so I can have the square root of z minus the square root of x, z minus x, times the square root of z plus the square root of x, the square root of z plus the square root of x. So this is called rationalizing the numerator. Very, very important. Right, let us continue, guys. I have a problem with the phone. It's overheating, so I need to turn it every time to check if this temperature is still under control, so that it cannot just shut down, because if it does that, it doesn't even save the tutorial. So in here, rationalizing is going to help us a lot. Limit as z approaches x. So remember, I'm going to multiply like this. I'm going to say z times z. We dealt with this in grade 10 mathematics. You would know that the answer is z, and then I would have z, square root of z times the square root of x is the square root of zx minus the square root of zx minus x. This is very, very important because they would cancel out. Divided by what? That would be divided by, let's do the following. Let's say in here we have the denominator z minus x, the square root of z plus the square root of x. Now remember, I multiplied this with this multiplies with that, you get this. Now look what is happening here. Can you see this? So that we have the limit as z approaches x of 1 divided by the square root of z plus the square root of x. And what is the value for this? What is the value for this? And this has to be equals to 1 over 2 the square root of x. Why? Why in the bezita does it have to be in this way? Why? Now in here we can also rationalize the denominator. So let me just leave this for a while. Let me say limit as z approaches x of 1 over the square root of z plus the square root of x. I can rationalize the denominator, square root of z minus the square root of x, square root of z minus the square root of x. I'm rationalizing the denominator. So the limit as z approaches x, that would be this times this is this all over. Let's multiply this with this. So z times square root of z times the square root of z is z minus square root of zx plus the square root of zx minus x. Can you see this? Right. Now when we are in here, now remember, I will have the limit as z approaches x, and what is happening here? This is z 1/2 minus x 1/2 all over z minus x, and I can say the limit as z approaches x of z minus x 1/2 all over z minus x. Very, very important here. Now the limit as z approaches x, So if I cancel, when I divide numbers of the same basis, I subtract the exponent. So that would be z minus x into 1/2 minus 1. The limit as z approaches x, that would be z minus x into minus 1/2, which is equals to 1 over the square root of z minus x. Are we fine? And remember, z is approaching x. So when we are in here, let us try to check this. When we are in here, let us try to check something here. This should give us 1 over 2 the square root of x. Why? Because we know that if f at x is equals to the square root of x and f at x is equals to x 1/2, if we want f prime of x, what is it that we do? We bring down, then we subtract. 1/2 minus 1 is minus 1/2, which is 1 over 2 the square root of x. That is why this is equals to that.